Hello and welcome back to the Go-Stroid development series. In today's video we'll be covering a really basic score manager and a really simple UI that we can update with our new score and score manager. Instead of just doing the big explanation, I'm just going to kind of get into it. There are some really quick changes that we actually need to make first, and to put this in a very simple way, past me, if you remember correctly, said I'm going to do this a certain way, specifically the UI container and how we're doing the level here. I'm going to do this way, and future me can deal with it. Well, now future me has to deal with it, and future me is very unhappy with past me. So let's fix this problem real quick. So the first thing we're going to do here is we're going to click main, we're going to use Control A or Command A, and we're going to create a new child of type node2d. Now we're going to rename this node2d to level_container like we had originally. Going to move that above the entity container like so, and we're going to pull level 1 down into the level container. Now that's going to cause this little issue here where we have this one tile in the top left corner that is just the background, right? Now if I press play, you'll see that's not right. Something's just off with that, right? It doesn't look correct. So to fix this, we're going to click on the level container, go to transform, and we're going to change its position. Now, its position will depend on what your screen size is, right? So we'll go project settings, we'll go down to display window, and we'll see the viewport width and height. Now, for this to work, we need to have our level container in the centered position. So it needs to be completely dead center of our screen. So to get that, what we have to do is we'll load up a calculator, we'll look at our viewport width here, we'll go, okay, 1152, so that's the width, and we'll divide that by 2, set that equal to whatever this is, and 576. Okay, so what we can do here is close that out, click on the level container here, pull up our calculator to remember what it was, 576 in the X position, so 576, that's centered it on the top line. And the last one was 648, so 648 divided by 2 is 324, or 324 in the Y position. So as you can see, that centered the node for us. Now, as I said before, this really depends on your viewport width and height. So if you don't have matching heights to me, just go through the same process that I went through, where you divide the width by 2 and divide the height by 2, and that's what your centered position will be. So with that out of the way, let's move into the level 1 node here for our level 1, which is a control node. Let's go to layout. And now we need to give this a custom minimum size. So the custom minimum size is going to be the same size as our current screen. So once again, window, viewport width, viewport height, 1152 by 648. So 1152 by 648. And now we are back to square one with some actual things moved around correctly. Now that wasn't that big of a deal, but past me should have just done that immediately and not left the problem for future me. So let's go and check. Let's go press the button here. Let's go destroy a rock. We'll see if we can destroy a rock. We've got the timer set quite high by the look of it. Let's maximize the screen and make sure there's no weird screen related issues. There are black bars here, but that's kind of normal. That's all how we want it to be. So what's the next thing we actually want to do here? Well, for the manager system, we're going to need to have some globalized signals, right? We're going to need to be able to move a value back and forth from certain things, say an asteroid, right? Say we destroy an asteroid. The asteroid should know how many points it's worth, at least. So the asteroid, when it gets Q-freed, needs to send out a signal so the score manager can listen to that signal, increment the score by a certain amount of points, and then the score manager needs to send out a signal to have our UI, or the UI that we plan on using, to update to the new score. So that might sound like it's a bit confusing, but let's just kind of go through this really quickly. We'll go down into our file system, into auto loads, into our signal bus. We'll go and basically add 2 more signals here, right? We'll do the first one for signal. This will be for increasing the score, so we'll go signal increase underscore score, it's going to need something to increase by. So we're going to do points underscore to underscore add of type integer, like so. Now we'll copy that signal. We'll go and create an emitter function for it. So func emit underscore, and then paste the copied signal in so we can just create it really quickly. A void return type, of course. And now inside the function, we just need to increase the score, or emit the increased score signal like so, and then pass through the points to add. So that is the increase score signal setup. Now let's go and create a new signal. We'll go signal get underscore score. So this is going to be a getter signal. So it's going to require the current underscore score of type int. And now I would like you to very quickly just go and set up another function like this for the get score. To do that, we will just go func emit underscore paste. I didn't copy the correct code there. Oh well, we'll just do this and we'll pass through the current underscore score like so. Void return type, and we will emit the get score signal like so. And now we'll use Control S to save, or Command S to save. So we now have our two score functionalities inside of our signal bus. So these are global score functions or global score signals, right? Anything can use these, which is really useful for what we want to do. So the next thing we want to do is actually go and into our health handler real quick, right? Because let's check our large asteroid. When our large asteroid gets Q-freed, it does nothing, right? And there's no way of the large asteroid to know that it's actually about to be Q-freed, because the thing that's handling its destruction is the health handler. So that means the health handler needs to have something inside of it that allows its parent to know that it's about to get Q-freed. Now, we did something very simple with this, with the projectile here. If we go into our base projectile and we scroll up, we grab the hitbox handler, and then we connected the hitbox handlers. There we go. On hitbox handler projectile hit. So the projectile hit signal from the hitbox handler got connected to the base projectile. That means we can actually do the same thing with the health handler here. We can create a signal inside of the health handler. We'll go signal, we'll call it on underscore death. Then we'll hit Control S or Command S and save. We'll scroll down to when our thing is about to get Q-freed. We'll emit that signal on death under the handle health function here. So on death dot emit. Hit Control S or Command S and save. And now we can actually go to our large asteroid. We can do an onReady version, or an onReady variable, or an exported variable for our health handler. I'm going to do an export variable here. We go at export var health underscore handler of type health handler, so that equal to null. We can now do something based off of the health handler's specific hit Control S or Command S to save, based off of that specific signal. So let's actually go and open up our large asteroid here. Let's go large asteroid scene, TSCN. Grab the health handler, go to node, signal, and you'll see here we now have the new signal for on death. So let's double click that, double click on large asteroid, it'll create a new function for us. I'm going to add the void return type to that just to make sure everything knows that is a void return type. What do we want to do on death? Well, we can now emit a signal, or pretty much anything we want, just before it goes kaput. So let's add a score amount to the asteroid, right? We'll do one more export variable. It will be for, we'll go score underscore value. It will be of type int, and we'll set that equal to 100, like so. Now let's scroll all the way back down into the on health handler on death function that we just connected. Let's call the signal bus and use dot increase score. So we have that increase score signal, right? So we want to emit that. So we'll go emit underscore increase score, and we'll pass through the score value. Now we can hit Control S or Command S and save. And what this is now doing is we are now emitting the value of the asteroid score out into the universe. Anything can listen to that, right? Anything that we want to listen to, it can listen to it. If I really wanted to, I can make the player listen to this and then print out how much value that score was. But instead of doing that, we are just going to go and create the score manager, and that will listen for us. So to do that, we're going to hit the plus icon to create a new scene. This will be of other node. We'll just make it a basic node type. We will switch to the 2D scene real quick. There we go. We will call this the score manager. Use Command S or Control S to save. Save that under scenes, under managers, hit save, and then we'll go and add a script to it. Do the normal thing of giving it a class underscore name of score manager. Now we can start doing things with it, right? We will need access to the ready function here. Just get rid of some of these comments. There we go. So we'll need access to the ready function, and we're going to need a variable for the current score that we are at, right? Because we want to contain that data. So we'll go var current underscore score of type int, set that equal to 0, right? Because we want to start off at 0 score. Now, in the ready function here, we want to connect to that increase score signal we fired. So to do that, we will use the signal bus or call the signal bus and use dot increase score dot connect, and we'll connect that to the increase underscore score callable. What is a callable? Well, let's go and set that up now. A callable is a function that gets called when the signal gets listened to, or when the signal is received. So to create that, we just write func, and then we paste in the name that we have connected it to. So in this case, increase score. So func increase score. What does increase score take? Just to make sure, we can go to the signal bus and have a look. It takes a points to add, and then an integer. So let's copy those, go to the score manager, inside these parentheses here, paste that in, and then do void return type. And what do we want to do? Well, it's increase score, right? So we want to increment the current score. So let's just go current score plus equals points to add. And that's it. You now have a really, really simple score manager, right? This is keeping track of the current score. That's actually what we want to do. We can go and do print, and we can print the current score out. I'm going to make sure that this works by doing what's known as a string conversion. String conversion is writing str, so to string basically, and then parentheses and what you want inside of that, or what you want to be a string goes inside of that. This isn't always necessary, just a habit you can kind of get into. So let's actually go and test and make sure this functions, right? Let's go into main. Let's go into the manager container. Let's use Command Shift A or Control Shift A. Let's then add the score manager in. Let's go back to our large asteroid real quick. And we need to go and make sure that the large asteroid actually has the health handler attached to it, like so. So now it knows exactly what health handler it needs to attach to. Now what we can do is we can hit run project, and I can go and destroy a rock. This might take a few seconds. And there it goes. And you can see down here in the output, we now have 100 score. Let's go and make sure that actually improves. Right. I'm missing. My aim is very bad. And there we go. Now it's at 200. So we are now keeping track of the score by hundreds. That's perfect. That means we actually have a score. The last thing that we really need to do here is actually make sure that our that our players can see what their score is. It would kind of suck a little bit if you didn't get to see what your score currently was. So let's go and make sure that's a possibility. First things first, go back to the score manager, and instead of printing the score out, we're going to use that other signal for getting the score. Now, a really, really simple thing that people kind of do very quickly without thinking is they'll call, like in this instance, they'll call the signal bus and they'll use dot emit, get score, and they will just pass through the current score like so. This is okay to do. What I like to do is create a new function, so func get underscore score like so, then give it a return type of int, and then we just write return the current score. Now this might seem like it's a bit unnecessary, but I actually really like doing this because it means everything that might need the score for some reason will just be able to use this function, and it saves me from having to create it in the future. So now what I can do, instead of emitting get score, I can emit get score and in parentheses just call the get score function. So what this will do is just return the current score, same way as if I just put current score in here. But I just prefer this method. It just feels a little bit better and feels a little bit like it's smoother, right? That way when in future I need to have something else that gets the score, it can just call that function and I don't need to change any of this stuff. It's really nice. But with that done and our score being got, we can finally move on to just creating UI. Now, the UI for what we're currently going to have is going to be really simple numbers at the top of the screen, right? A little test UI. So to do that, let's go and create a new scene of type user interface. We're just going to call this the UI, like so. We're going to hit Control S or Command S and save. I'm going to give this a new folder inside of the scenes folder called UI. Hit save, and now we'll add a script to it. We're going to go give this a class name, so let's go do that. Class underscore name of UI. I'm going to make sure this is known as UI underscore control. Now there is a reason why I like to do this. In my previous series, I kind of explained this a little bit, that I like to either put control or UI after the UI specific nodes, so I know exactly what they are, and I usually like to do it in all caps. It's just a little naming convention that I like to do. You don't have to do this. So for the UI, what do we need? Well, we've got the script ready. Let's just go back to the 2D scene real quick, so we can kind of look at this in and understand how UI kind of functions for Godot. So if I click on the UI here, you'll see that this orange box appears. Now this is a full screen rect or full screen rectangle of how much the UI is currently covering. So this is covering the full screen, right? That's how large this UI is. And that's fine. That's exactly what we want. You always want the primary node to do pretty much a full rect in most cases. So that means what I can do now is I can use Control A or Command A. I can add something known as a margin container. Margin container is a container that keeps a margin around its child controls. So what that means here is, as you can see, we've gone to this little tiny box in the corner. If I set this in the anchor presets up here to full rect, which is the big white square, you'll see that it now covers the full screen, right? Makes sense. But if I grab the UI container and I scroll this in like so and go to the margin container, you can see that it's matching. On the other side, if I pull in the margin container more and then go to the UI container, it's no longer matching, it's out of sync. That means if I, of course, go and set this to full rect, and then go to the margin container, it did increase its size, but not to the same amount as the UI. That's kind of how control nodes work in Godot. But the margin container has something very specific that I'd like to take advantage of, and that, if we go into the inspector, under theme overrides, under constants, is the margin. This just really allows you to add a little padding to each side of the screen. It just makes it look a little bit better and a little bit more cozy rather than all kind of just jammed to the corners. So I'm going to just add a quick margin of 12 pixels in every direction. And then inside the margin container here, I'm going to use Control A or Command A. I'm going to add a label. As you can see here, the box isn't touching the right and left side. It's kind of pushed in a bit, and I like that. We're going to make the label go to the center in horizontal alignment and then in vertical at the very top. So as you can see here, it is now centered on the top of our screen. So if I do, say, 3 zeros, you can now see that we have 3 zeros at the top of the screen. Now let's finally go to that script for the UI that we were just kind of talking about and making. I'm going to remove all of the code in here for now. we want to kind of update the label, right? The label is what our score is going to be contained as. So let's actually rename this label. We'll rename it to score label, so we fully know what it is. Let's create an onReady variable for it as well, like so. So as a quick reminder, if you don't know how I just created that, let's delete that. We will click, drag, and use Control or Command just before we drop, and it will create the onReady for us. Then we'll typecast it as a label. Now we have access to the score label and all of its functions, or label-specific functions. The next thing we're going to want, of course, is a variable for the current label score. So let's go and create that. Var current underscore label underscore score of type int, and we'll set that equal to 0. What is this going to be? Well, do you want to keep track of your current score in your score manager usually, but keeping track of what the current label score is set to is mostly just nice for when you want to do the original setup, the first time setup. That way you could just immediately set your score label to 0. Why is that important? Well, if I go into the text here and I just do a bunch of random letters and words and spaces and symbols, and then I go back to 2D, you'll see that this is a thing. And I'm going to leave it like this because with what we're going to do, it will automatically change this to 0. So let's go and kind of set that up, right? We know that we are emitting a signal from the score manager here for get score. Well, that means that the UI here can listen to that, which means we need to connect it through the ready function, right? Because that's how we connect to global signals. So let's go and get access to the ready function. Let's call the signal bus dot get underscore score function or signal that we made, and then use dot connect, and we'll connect it to set underscore score underscore label. Once again, we will copy that set score label name that we just created. We'll create a new function, paste that in, and what does set score label take? Well, it takes a current score of type integer, void return type, and that's it, right? Because that's what the signal or the actual function here actually is supposed to take. So that means we can now just grab access to our score label and then use dot text. So let's just do that. Let's go score label dot text is equal to the current score. There we go. Now you'll get an error when you try to run this, and that is because current score is a value type of integer and not string. Well, that's where the string conversion comes in. So let's just use str like so, and then wrap those parentheses around the current score, and use Control S or Command S and save. We'll go back to the main scene here. We'll go to 2D. Under the UI container, we use Command Shift A or Control Shift A. We'll put that UI in there as well. There we go. As you can see, UI is there, but as you can see, the text isn't showing, and that is because of that other issue that I didn't correct yet. And that's because in the second episode of this series, we set the UI container layer to -1. We want that set to 0. Now, before I apply any more fixes, we're going to run this, right? And we're going to see what happens. As you can see here, we've got a long random string. If I press play, that's what should be at the top of the screen, and it is. But if I destroy a boulder really quickly, and it was that one, it's now set itself to 100. That's really cool, but what would be even cooler is if it automatically set itself to 100 without us having to do anything. So let's go and set that up. We'll do this very simply, right? One, we're going to keep track of the current label score anyway, so we'll grab the current label score inside of the set score label here, and we'll set that equal to the current score. That way, this number is always going to be the same as this number, technically speaking. And then, instead of setting the .text equal to the current score, we're going to set that equal to the current label score, and then use Control S or Command S to save. And finally, inside the ready function here at the very top, we're going to call that set score label function and just pass through set label score. Because on ready, this will be set to 0. Current label score will not be set any higher than 0. It should only ever be set to 0. That means it will set our score label, this function here, to 0. That's it. That it should completely be done, actually. Yeah, there you go. We are now set to 0. Now, I don't like the size of that, so we're going to very quickly go to the UI here under 2D. We'll click on the score label. We will go down to theme overrides, font sizes, and we'll change that font size to 32. Now, that looks a little bit large, but if I press play, that looks perfectly sized to me. Now let's go and destroy a boulder and 100. Let's go destroy the other one. 200. So our score will now pretty much increment infinitely until we either do something or hit a cap or, set something up to handle it going infinitely. But that is how to set up a score manager and a quick score UI. In the next video, we're going to be handling probably more score-related things, or we're going to rework a little bit of what we've done today to add a death handler of sorts. That way, and probably actually separate large asteroids into resources, which I just thought about, which will be interesting. That way we can have asteroid resources that handle all of the scoring for them, which is a good idea, actually. That's probably what we're going to do in the next episode, so I will figure that out then. But yes, thank you for watching. I hope you've had a great day and a great game dev journey. If you have any questions, please come down to the Discord. A link is in the description. And yeah, I'll see you in the next video.